Hi, it's time for another math easy solution. Today we're going to discuss further into calculus with parametric curves and look further into tangents and go over the general condition for basically the derivation I went over for the equation for the slope of a tangent line on a parametric curve. And basically, so the general condition for determining tangents in my earlier video, just to get a just to summarize what I did, if you go here, I assumed we could rewrite the parametric equations x equals f of t and y equals g of t in the form of y equals f of x. So if I open this up, you can go and click here, view the notes. Yeah, and here are the notes right here. And basically in that video, you could put the link below in the description. You could go and view it. But basically, I just assumed, and I stated that I was going to do the general condition in a later video, and I just assumed that some curves defined by these parametric equations can be expressed by eliminating the parameter in the form y equals f of x. And then from there, I determined that the slope would be equal to this over here, or in other words, dy over dx is equal to dy over dt over dx over dt, where the bottom one here is not equal to 0. Otherwise, you have a undefined slope, where the bottom part here, dx over dt, is a derivative f prime of t, like that. So let's jump over here. So in this video, I will look at the general condition for which this is possible to eliminate the parameter through the following exercise. The exercise states if f prime is continuous, and again recall that it can't equal 0, and we have that condition here, and also f prime of t is not equal to 0 for the interval t is between a and b. Show that the parametric curve x equals f of t, y equals to g of t for, again, between a and b is the parameter t, can be put in the form y equals f of x. And the hint, this was given, this is from my calculus book, states, show that f, the inverse exists right there, the inverse of f. And the reason for that is, well, let's just write down what we have now. So we are given that f prime of, so we have f prime is not equal to 0, or f prime of t is not equal to 0, for a is less than t less than equal to b, like that. And we're also told that it's continuous. So f prime is continuous. So if it's continuous and it's not equal to 0, thus we have two conditions. Thus, what we either have is f prime is greater than 0, or f prime is less than 0. In other words, it's increasing or decreasing. Yeah, the function f is either increasing or decreasing, because it can never cross a 0 and it's always continuous. You can't just jump values. You have to continuously move along. So if we were to graph this visually, we'll have, this is t, this is x. So for the first case, if we have, let's say, a like this, and up to b, so from here to here, it can only increase. So we can only do something like that, where it's increasing. This is x equals to f of t, and this is where f, this is greater than 0, so it's always increasing. Or we have the condition where it's decreasing. If this is t, this is x, like that. So you have a, this is b, so it's either we go down or we go up. In this case, we have it going down always, because it's never equal to 0, so you're always going to be decreasing. And this is our x equals 2 f of t, and where f prime, or the derivative, is less than 0. And now, since we have this scenario, well, this equation has an inverse. That's because this has a one-to-one function like this. If we go here, we have a value t, and then for every x value, we have a value for both conditions here. So if we have value t here, we have an x value there, and it's always 1-to-1. So thus, what we have is f is 1-to-1, and as I've gone over my other videos, I'll put that in the link below as well. So thus, f is 1-to-1 and has an inverse. And again, remember, inverse, all you do is switch. So it has an inverse, i.e. you could just swap y for each x. That's basically the definition of an inverse. Stems from the idea that you could just swap y for each x. So in other words, what we have is if we have x equals 2f of t, then because the inverse exists, we can just swap these around. T is equal to the inverse of this is to the power of -1 like that of x like that, and this is basically the exact same thing. This just means that we could just swap these left and right. So x equals to f of t. T is just going to be the inverse of f of x, like that, same way of writing it. Because for each x there's one t value, for each t there's one x value, like that. And that's how you would write the inverse. So now what this means is, so thus what we have is, well, we know that the second parametric equation, y equals to g of t, that is the second one. We have x equals f of t. But now if we write y equals g of t, because remember at the end of the day we're trying to find out y is equal to a function of x. So what we have is y is equal to g of t, but now that we have t as a function of x, it's the inverse of it, then we could, well, throw this inside. So when we do that, we end up having g of, now we have f inverse of x, like that. Notice there's no t variable, all there is x, so we have g is a, so we plug in the t from the x parametric equation. It's a function of x, it's the inverse. Plug that inside here. So what we have is, quote, a function of x. Because, this is just g of inverse of f of x, but at the end of the day, it's still a function of x. So we could combine all this together and write this as capital F of x, like that. Write this a bit neater. So we have a function of x, like that. In other words, we have y equals to a function of x. I'll write this down over here, equals y. So in there we have it. So then the only condition is, well, we need to make sure that f prime is continuous and it's not equal to 0. Or f prime of t is not equal to 0, because as shown here, we can't have the bottom part here, f prime of t equals 0, otherwise the derivative is not going to be, it's going to be undefined because you're dividing by a 0. And that's basically it, as long as it's continuous, and that one is not equal to 0, so we're not dividing by 0. And that's the condition, and just basically by finding the inverse. Anyways, that's all for today. If you learned and hopefully you enjoyed, and like always, you can download these exact notes in the link below. Thanks for watching, and stay tuned for another math easy solution.